Okay, so we're going to continue on in chapter 6, and now we're going to look at confidence intervals to estimate the population variance or the population standard deviation. Again, the requirements are the sample must be a simple random sample, and this time the population must be normally distributed even if the sample is large. All right, so now we're going to be dealing with a different distribution. It's known as the chi-square distribution. Chi-square distribution is a distribution that is skewed right, and it follows this formula, n minus 1, where n is the sample size, the sample variance over the population variance. We can either use table A4 or Minitab to find chi-square values. And remember, degrees of freedom are equal to sample size minus 1. Chi-square is not symmetric. In fact, it's skewed right. And the values of chi-square are always greater than or equal to 0. And the chi-square distribution changes slightly as we change our degrees of freedom. Note, we must find two critical values. When we were doing critical values for the z distribution or the t distribution, both of those distributions were symmetric about the 0. So that if we found the left critical value to be negative 2.575, we knew the right critical value was positive 2.575 because that's the value that's found opposite on if we fold it on the 0. But since all of these values are positive, they're not symmetric, and you'll need to find both critical values separately. In the table, it finds the area to the right, which is different because Minitab finds area to the left. And chi-square left corresponds to the area to the right of this, or for Minitab, we're doing area to the left. And chi-square right corresponds to area to the right of alpha over 2. This is the formula if you were doing this by hand. Now, because Minitab doesn't do this, I want you to be aware that this is what you would do if you had to do it by hand. But I'm not going to have any problems on the homework or the test where you have to use this formula. Because Minitab doesn't, the student version does not do a one sample variance. If we were on campus and we have the professional version on all our computers on campus, we could do a one sample variance. But you have the student version at home, and so we can. But we can use Minitab to find the chi-square critical values. Now suppose if we wanted to find one, now I will ask you to do a few of these in homework. Calc, probability distributions, and then choose chi-square. If we're looking for a 95% confidence interval, then 0.025 is to the left of the left critical value. So you would enter in the input constant 0.025. That would give you the chi-square left value. If you were trying to find chi-square right, you're looking for the area to the right. So it's 1 minus 0.025 or 0.975. You would enter in the degrees of freedom and you would get the right critical value. All right, so total area is what divides our two left tail and right tail critical values. And to find the minimum sample size, we would just use table 6.2 on page 305 to find the minimum sample sizes. Okay, so we're going to continue on with Chapter 6, finding confidence intervals. Now we're going to look at confidence intervals to estimate the population variance or the population standard deviation. The requirements are the sample must be a simple random sample, and the population we're drawing from must be normally distributed even if the sample is large. The chi-square is a distribution that follows this. where it's sample size minus 1 over the sample variance divided by the population variance. And we can either use table A4 in the back of your book or Minitab. And chi-square depends on the parameter degrees of freedom, which if you recall is equal to sample size minus 1. Chi-square is not symmetric. In fact, it's skewed right. And it is not symmetric. It is not even centered at the 0. All the values of chi-square are greater than or equal to 0. And each chi-square distribution changes as we change the degrees of freedom. So first, note, we never had to find both critical values because the t-distribution and the normal distribution were symmetric about 0. So if we found the left critical value to be negative 1.96, we knew that the right critical value was positive 1.96. You only had, because it was centered at the 0, we just needed to find either the plus or the minus, and the other was they just changed the sign. The table in the back of the book finds area to the left, and Minitab uses area to the left. Now, if you're using the table, the chi-square left corresponds to area to the right of 1 minus alpha over 2. And chi-square right corresponds to area to the right of alpha over 2. I'm going to show you how to use Minitab to find these critical values. But if we were doing these confidence intervals, this is the formula by hand. This is the formula we would use. And if we were estimating the population standard deviation, we would just take the square root of both of these lower and upper limits. Now let's use Minitab for standard deviation. Now, if you were on campus, we have the professional version of Minitab, and it does have the capabilities of doing a one sample variance confidence interval or a one sample confidence interval for standard deviation. But the student version that you all have at home does not do it. So you will not see any questions on the test or the homework asking you to find the confidence intervals for variance or standard deviation. I just want you to be aware that you could do it, and if you either have to use a more powerful statistical software, a professional version of Minitab, or you do it by hand using the formula. But the one thing you can do with Minitab is find these chi-square critical values. So you go to Calc, Probability Distributions, and then choose chi-square. Now, if we're looking for the critical values for, let's say, a 90% confidence level, then 90% is in the middle, and we have 5% left over on either tail. So to find chi-square left, we would enter in the degrees of freedom, which is sample size minus 1, and our input constant would be 0.05 because that's the area shaded to the left of chi-square left. And you would get a value. And then to find chi-square right, you would find the area shaded to the left of chi-square right, which would be, if for 90%, it would be the whole 90% plus the 5% in the left tail. So you would be entering in 0.95, and that would give you chi-square right. I'm going to give you a couple problems to try in homework, but not on the test to do this. So that's how we could do confidence intervals for estimating population mean and standard deviation. Remember, we looked at the theory, but because Minitab doesn't do it, we're not going to do this on our test and on our midterm. All right, so notation, remember the total area is divided equally between the two tails. And if we wanted to find the minimum sample size, the formula is quite complicated. So instead, we're going to use table 6.2, which only does 2 confidence levels and only does certain margin of errors. But if I ask you a question on the midterm using this, or for homework, it'll be one of the values that is in table 6.2. Notice one side is for confidence intervals for variance, and the other one is for confidence intervals for standard deviation. Make sure you understand how to use the table. I will give you a few homework problems before so you can check your answers. All right, that is the end of chapter 6.